Welcome, guys. So, I would like to continue from where I stopped in the previous video, where I said I will be dropping the video containing the graph of the WAEC past question I worked on based on the illustration of how the WAEC 2024 physics practical will look like. So, I would like to show you how you can plot your graph because physics experiment is not complete until you have a reasonable graph drawn. So that experiment where we calculated the angle, we measured MO, we measured NO, and we evaluated the value of phi to be MO over NO. And we also worked on cos theta. Then the theta you can see in that guide was that theta is the required angle. The angle you used to measure the value of MO and NO. So that angle of 70 we use 65, 55, 45, and 35, which I said you should complete the table then. I said you should use your calculator to measure the value of MO over NO. So I've done that, and this is how the table looks like. So the graph, you were being requested to plot a graph of cos theta on the vertical axis and phi on the horizontal axis. So vertical is this standing aspect and horizontal is this sleeping aspect of the graph. So the next thing I notice is that whenever students want to plot graph, they sometimes find it difficult to deduce the convenient scale, and without a good scale it will be difficult to illustrate the data on the graph. So when looking at this part, we now notice that the value of the least value of phi here is 0.212. Okay, and I can see that the highest value is 0.519. So with these readings I have, I can just decide on my own regression. Your scale depends on you, but you have to indicate on the graph the scale you've used for that experiment. So on this one, I would like to use for the horizontal axis. So I'll write it, there's a space provided on your graph for horizontal x-axis. I would say let 2 centimeter represent 0.1 unit, and on the y-axis I will also let me use the same thing, because on the y-axis the least is 0.3, the highest is 0.8. So when looking at this, it will contain, since the total on the vertical is 12, so it will contain 0.8. So let me go, let 2 centimeter represent 0.1 units, and this is a graph of cos theta against phi. Okay, so I'll go on by deducing my, so I will rule. Let's go straight to the point. Okay, let's start from here. So I rule my vertical line, which is the cos theta. Okay, I will rule my horizontal. Okay, so I will label the graph. This is the origin, the 0. This is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and on the horizontal, since I'm using the same scale, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. You can stop since the highest is 0.519. Okay, so the next thing to do after that is to start imputing my data one after the other. So when phi was 0.212, now for you to be able to calculate the value of this small tiny box you have in the big 2 centimeter, it is advisable that you estimate or you approximate this value to the nearest two decimal place. You can see here I have it in three decimal place. So me looking for three decimal place here might be a little bit stressful. So approximate this to the nearest 2 dp, and without two decimal place to be much more easier to work on this. So 0.212 when phi was, so I'll label it, this is cos theta, and this side represents the phi. So I will go on. When phi was 0.212, the value of cos theta is 0.342. So when this one was approximation 0.21, this one is 0.34. So I will count this 0.1, 0.2. So the next line should be 0.21. This next small line. So 0.21. When this one was 0.21, this one was 0.34. This is 0.3 here, as you can see. So move to 0.34 on that line. So I'll trace this up. It is 0.3. Okay, good. So 0.31, 0.32, 0.33, 0.34. And I'll put a plus or a circle at that point to note my point. So on to the next one. When phi is 0.2, approximation is 0.28, the cos theta is 0.42. So 0.28 is 0.25, 26, 27, 28. So I'll trace it up, trace it to 0.42. So this is 0.4, 0.41, 0.42. Now put my plus or asterisk depending on anything you decide using. So the next one, when phi was 0.37, cos theta is 0.57. So 0.335, 36, 37. So I'll trace it up, trace it. This is okay. 0.5, 0.57. Okay. This is 55, 56, 57. And I'll put my plus. Okay, good. So when phi was 0.45 approximation, this one was 0. Cos theta was 0.771. Okay, so it's 0.45, 0.45, and there. So trace it up so I can deduce the value of 0.71. So 0.4, trace it for 5, okay, and there for 5. Good, is 0.7. Then 71, the next box 0.71 here. Now put my plus. Okay. When phi was 0.52, cos theta was 0.82. Then I'll trace 0.5, 51, 52. I am there. Then cos theta was 0.82. This is 0.8. So I'll move up 0.55152. Okay, then 0.82. This is 0.8, 0.81, 0.82. Then I'll put my plus. Okay, good. So these are my points. And the next thing is to join the point with a straight line. As you can see, the graphs look straight. So just follow it up. Draw the something with a straight line. Okay. Okay, one thing I would like to clarify or talk about is that when it comes to physics practical graph, it is not mandatory, it's not compulsory that your line, the target or hit all the points, but at least you must be able to pick at least minimum of 3 points for you to call it a successful and a good graph. So as you can see, I have a minimum of three. One, two, three. That are perfect. So this one falling out of the line doesn't mean the graph is not correct, as well as this falling out. So since I have this done, then I've drawn the graph. Then you continue reading the instruction. The instruction says based on that WAEC 2011, they said Determine the slope S of the graph. So how do we determine the slope? To determine the slope of a graph, pick two convenient points such that it will be easier for you to locate the values. As I can see here, I know the value of this point that is hitting the graph well, and I know the value of, let me pick a bigger one, this one that is hitting the graph well. So I will just quickly join the two. I will trace this one down. Okay, as you can see, I'm coming over here. Okay, okay, good. And I'll join this as well. Okay, so the slope, then I'll trace this down. I know what this value is, and I'll trace it. That's 0.82 for this. So slope, the slope simply means the change based on mathematics aspects, and the same thing. Slope means the gradient, and gradient is the change in y-axis with respect to the change in x-axis. So the y-axis represent the cos theta, so and the x-axis represent the phi. So the slope will be changing this cos theta with respect to change in phi. So that is change in cos theta divided by the change or delta change in phi, and the slope s will be equals to the change. So what is this value? Y2, that's 0.82 based on the table. That's 0.82 minus change means the difference. 0.82 minus what is this point? 0.34, 0.34, 0.34 divided by what is the change in phi? This point, trace it down, that is 0.52, 0.52 minus this point, trace it down, 0.21. You can see here 0.21 minus 0.21. Okay, so that's on that. Then I will deduce my answer, and that is the result for slope. Subtracting this, you get a numerator, then subtracting this, you get a corresponding denominator, then divide. You've gotten the slope. Slope is not as difficult or as simple as that. So simple. So the next thing after that is that they requested for you to state two precautions taken to ensure accurate results. Then when you look at the experiment very well, if you if when you were performing the experiment you made an error, you committed a mistake, or you made a mistake concerning when you were fixing the pins, if the pins were not vertically being erected, the images of what you will see after the refraction through the prism will be a little bit affected. The values will not be in good position. The value will differs, and if the value is not correct, definitely it will affect your graph. So which means that one of the precaution taken to ensure accurate result of that experiment was that we avoided parallax error when fixing the pin on the incident ray, such that we ensure that the pins were being fixed vertically upright. That is one precaution. Another precaution taken is that we ensured neat traces, because when you notice that when I was tracing the outline, I ensured that I traced well to avoid error. So I ensured neat traces. Another precaution is that I ensured that those pins used are reasonably spaced. That is, when I fix the first pin, you will notice I ensure that there is a reasonable space before I fix the second one. And as well as after the refraction has taken place, I also ensure that when fixing, to check that those pins are on a straight line, I fix them perfectly with a reasonable distance between them to ensure accurate results, which I did perfectly. So that being settled, we are settled with that precaution. They requested for two. And the next thing is that they said state Snell's law. What is Snell's law? Remember, it is said that when you were given the laws of refraction, the two conditions, it said that the incident ray, the refracted ray, and the normal all lie on the same plane. Okay, fine. That's the first one. And the second one, which is what we refer to as the Snell's law, which states that so Snell's law states that the ratio of the sine angle of incidence to the sine angle of refraction is constant for a given pair of media. So that was what that second law of refraction stated, which is referred to as the Snell's law. So that is settled based on that question. And they said if the refractive index is 1.5, calculate the critical angle. When you were taught total internal reflection, you were being explained to that total internal reflection is said to occur when the angle of incidence in the denser medium is greater than the angle of is greater than 90 degree, which is the critical angle in the lens dense medium when it is exceeded. Okay, fine. For critical angle to occur, critical angle is simply that angle of incidence in that denser medium when the angle of refraction in the lens dense medium is 90 degree. That is critical angle. So from Snell's law, we know that Snell's law, which is pardon, let me write here so you see better. Refractive index is equals to sine I over sine R. So critical angle is that angle of incidence, right? In the denser medium, when the angle of refraction in this lens dense medium is 90 degree. So with that expression, the refractive index will be equals to 1 over sine C. This one here is when this one is 90 degrees and sine 90 degrees is 1. So that is why you have it to be 1 over sine C. We are given that refractive index is 1.5. So you are looking for the C. 1.5 is equals to 1 over sine C. So when you cross multiply, sine C is equals to 1 divided by 1.5, which is equals to something. So with your calculator, 1 divided by 1.5 will give me sine C is equals to 0.667. Then I will get my C by taking the reciprocal, the sine inverse of 0.667. So C is the sine inverse of 0.667 degrees, 0.667 rather, which is equals to 41.8 degrees. So 41.80 degrees. That's the critical angle. So with that being done, the practical is successful and completed. So thank you for watching. I appreciate.